Hello and welcome back to another VMK in the game development series. In this VMK, I've decided to do a little bit of cleanup work on our existing game engine. Let's go into Visual Studio and take a look. You'll remember that inside of our scene, we've created a structure here called m_p error handler. And this is a pointer to our error handler class, which is stored up here. And we use this guy anytime we want to log any errors or messages that we display to the screen. What I want to do now is go in and clean up how we're using this pointer to our error handler so that we can use him with different kinds of classes that we couldn't use it before. So for instance, with the font, we have a pointer to our error handler, and we create a new pointer every time we create a new font. Well, that's not really ideal because we know we're always going to have the exact same pointer to the exact same error handler for every single font. So we really only need one instance of this. We don't need to duplicate it for every single font. We're also going to go in and create the same pointer for the error handler into our light class so that we can use it inside of here as well as inside all of our individual light classes, so our spotlight, point light, and directional light. We'll add it into our material, we'll add it into our node so that we can use it inside of NodeLight, NodeShape, NodeTransform, and we'll also go in and add it into our texture and TextureTransform classes as well. Lastly, we'll go into our object lib and also add it to the geometry so that we can use it inside the box, compiled, cylinder, and flat grid. All of this will help us because anytime we load in data from a file, for instance, like this file here, testing.lvl, we create a Scenegraph structure which gets parsed into memory. But right now, we don't really have a way to do error checking to see that what we're constructing is actually what we're expecting. So by creating this new interface for the error handler, we're going to be able to output exactly what the Scenegraph contains to a file. And then we can go through, look at it, and make sure that it matches up exactly with what we think is supposed to be in there. This is also great to debug Caligari files because the previous VMK showed you how to create a Caligari file loader, but we don't really have a clear visual representation now of what our Scenegraph looks like. We should have an idea of what it should look like, but we don't have any direct confirmation of the Scenegraph structure. So in this video, I'm going to show you how to modify the error handler pointer here so that we can use it with every single thing that we use inside of our Scenegraph, and then we're going to be able to output the Scenegraph to a file so we can debug anything that we may need to later on. And I've created this in such a way that the output is going to match pretty much the same thing that we have here inside the LVL file. So if you do want to pass out your results to someone else, they could use it as if it's a regular LVL file and then load it into your program. Okay, so let's get started with this. First thing we're going to modify is the font class here. So we're going to open up font.h and we'll scroll down here into the variables section. Under the public, I'm going to add a static variable. It's going to be a pointer to our error handler, and I'm going to name it s_p error handler. We're going to be using this anytime we want to output anything to our log file. This means that we're going to go in here and remove our old error handler like so. Now, because this guy is static, we need to define an instance of this memory here. And the way we're going to do this is we're going to place all of the instances in the exact same location, which will be inside of scene.cpp, located right at the very top here. You'll notice we already had a static variable defined here for our alpha objects, so we'll just do this for the font one as well, like so. So we have a pointer to our error handler. It belongs to a font. Here's the variable name that we're defining, and we're initializing it to null. To actually define what is the value of this error handler, we'll need to do that inside of the constructor for the scene because this is where we pass in the pointer to our error handler. So in here we're going to define that our font's error handler pointer is equal to the pointer that gets passed in here into the constructor. Okay, let's go back into font.h now. we need to go in and modify a couple things inside the font CPP file. Anytime we use the m_p array handler, we now have to remove this guy and replace it with s_p array handler. We also don't need to pass in the array handler pointer into the constructor anymore, so we can delete that as well. So just scroll down through here, and anytime we used our array handler pointer, we just need to replace it with s_p array handler. I'm not sure if we actually used it in here. Looks like we did. Oh, we changed the constructor. We need to change it inside the .h file as well. Oh, I guess we didn't use the array handler in here. But don't worry, we are going to go in here and add an extra function to use that array handler, but for now, let's just leave it out. Okay. Let's also go and try to compile the CPP file, make sure we didn't make any mistakes. Okay, we have to modify anytime we use the constructor here to get rid of that first parameter. And there we go. So that's basically changing the font class. Now let's go in and change, let's see, what next easy one could be. Let's do light. So open up light.h, again inside of the public section, add a static array handler pointer, and save that. And going back to scene.cpp, right at the top here, define the memory we're going to be using for the array handler, and then define exactly what it's going to be equal to, like so. Let's go and make sure we can compile our light.cpp. Okay, that's good. Now let's go in and modify the material class. Opening up material.h, again inside of the public section, where we define our pointer, our static pointer, and then in scene.cpp at the top, we're going to define the memory for our static member, and down here we're going to define it, like so. So we can go in, open material.cpp, compile this. Okay, this guy failed. Let's see what's wrong with him. Oh, it doesn't know what an array handler is, so we need to go in here and include arrayhandler.h, or you could just include core.h, which includes arrayhandler.h. I'm going to include core.h just in case we're going to be using things later on in here that the material also needs. So let's go and try to compile this. Notice the systematic approach I'm taking. I'm only modifying one at a time and then compiling and making sure that what I change still works. This helps you a lot because you may introduce a small bug now, but if you don't compile while you're building your code, things can get very large very quickly, and your errors will start compiling one on top of another. You don't want that, so just to quickly figure out any bugs that you create, just compile as you're going. Alright, so we added material. Next one up, let's do texture. So open up texture.h, going down here into the public section, add the static member, and this time also remove the old member variable that we had here. Back inside of scene.cpp, let's go and define the memory for this guy. And then down in here, make the variable equal to the array handler, like so. Now we'll have to go into the texture.cpp, recompile this, and we are going to get error messages because We had the member variable here before, but now we're just going to rename him to use the static member. Oh, also looks like the constructor has to get changed as well. Like so. So I guess we could do a find and replace. That would be probably fastest. We're going to be looking for m_p error handler, and we're going to replace it with s_p error handler. We want to only make this change inside of the current document, so let's go find the next guy and replace, replace, replace. Just go through and replace all the instances of the member variable with the static one. There's quite a few in here. Okay. Now let's go and try to compile this, make sure everything's okay. That looks fine. And we'll have to go into scene.cpp, compile this. It'll give us an error messages if we are using textures, because their constructor changed. So going into here, just remove that first parameter for the constructor, since we don't need to pass in the error handler anymore. Okay. So the texture is done. Let's move on to the TextureTransform. Open up TextureTransform.h. Inside of the public members, we add our static member, and inside scene.cpp, at the top, we're going to add our TextureTransform. And down in here, we need to define it, like so. Let's go save this and compile. That looks okay. And TextureTransform, open the CPP file and compile, and that looks okay as well. So we can close that off. And let's see here, what do we have left here? Looks like we have node and geometry. So let's start off with the node. We'll open up node.h, and down here in the public members, add our static member, and back inside scene.cpp. Actually, I'm going to put the node one up here. Doesn't matter where you put it, but I'm just grouping them sort of in together here. And down here, we define our pointer. Let's open up node.cpp, compile this. He's okay, so we can close him off and compile scene.cpp. He looks okay as well. One more, we have the geometry. Open geometry.h. Inside of the public members, we define our static pointer, and then let's try and compile this guy. Oh, you can't compile him because it doesn't know what an error handler is, so we'll need to go in here and also include core.h. Compile him. He looks okay now. And we need to also define him up here. And finally, down here, like so. Let's go and compile this. Alright, if we were to build this, everything should still work exactly the same as it did before. And everything looks okay, that's good. Now, I want to add in the functionality to be able to output the scene graph to a file. The way we're going to do this is we're going to create a new class, or sorry, not a new class, but a new function within the scene class. So let's open up scene.h, and if I scroll down here Okay, functions to interact with Scenegraph. I'll put it under here. We have output Scenegraph log. So what this is going to do is going to output everything inside of the Scenegraph to the log file. Save this and go inside scene.cpp. You can put this function pretty much anywhere. So I'll just put it right here on the very bottom. Okay. First thing we're going to do is we're going to use our error handler to output this long underline. This is just a bunch of individual underscores grouped together to give you this line. Then what I'm going to output is all geometry objects. So this is just a string, and notice that I put the 2 slashes in front of this. I do this specifically so that as this log file is generated, we can then go and cut and paste it into a LVL file later on and still use it as a loader. Also, I put a /n here in front to put a carriage return at the end of this underscore line here. Then what we're going to do is we're going to go into a for loop, and for every single geometry, we're going to call this new function called output tree. An output tree is responsible for outputting all the specific information about this specific geometry. So what we need to do is create this function inside of the geometry class. So let's go into geometry and create this function. I'm going to make this function a pure virtual function, forcing every class that inherits from geometry to implement output tree. So here we go, we have virtual void output tree, gets no parameters, and it's equal to 0. Now that we have that defined, we need to go inside every single class that inherits from geometry and implement that function. So inside GeometryBox, we're going to have void output tree. We're also going to add it in here into GeometryCompiled. We're going to add it into GeometryCylinder and GeometryFlatGrid. Okay. Now let's go into GeometryBox.cpp and actually implement this function. And again, I'll put it right at the bottom. Location doesn't matter. So we have output tree. We'll create a variable called setOutput, and it's 1K long. The string of text, which we are going to create here, is going to contain all the information about this geometry box. So to start off, we're going to write down that it's a box. The geometry ID number is going to be the ID number of this class. So in other words, it's going to be the memory location of this class. So I'm just going to use the this operator, which is a pointer to a geometry box, and save that inside here for the geometry ID. We then go and check to see if the width, depth, or height parameters are not their defaults. And you'll remember that the default value is equal to 1. So if it's not 1, then we output that the current string outputs back to the current string, and then we add this string here, which is the width of this current box. We then do the same thing for depth. So we take the current value of the string, output it to itself, and then we add the depth parameter here. And finally, we do the same thing for height. So if the height is not equal to the default, we also output it. Once we've got this string here with all the parameters specified, we then go and use the static error handler pointer to output the string of text to the log file. Now notice that I'm using there is no error here because we don't want to display the static text to the screen using a message box. If we had something else here, then a pop-up message would appear on the screen later on. But we don't want that, so we need to specify here no error. So that's the way we handle the geometry box. Let's go and compile him, make sure he's okay. And he is, that's good. Now we can go on to the next guy, which was GeometryCompiled. Back in here into CPP. GeometryCompiled is a little bit tricky because we don't actually have any parameters that we can view. You'll notice that inside of the GeometryCompiled.h file, all the member variables that we have is just the ID number for the display list that OpenGL uses. So really, we can't display any parameter information about this, like number of vertices, number of faces, things like that. If we did save them inside of this GeometryCompiled class, we could then output it. We don't have anything like that, so all we're going to do is display / compiled geometry ID and then the number for this memory pointer. Let's go compile this. He's okay, so we can close him off and move on to the cylinder. Again, we create a variable here to hold the string of text we're going to be outputting to the log file. We started off by saying it's a cylinder with the geometry ID value of this, and then we check for the parameters. If they're not the defaults, we output them to the log file. So here we output the radius, the height, the number of sides, and then smoothing. If it's smoothed, then we don't actually output anything. But if it's not smooth, we output _0. And then finally we use the static error handler pointer to output the string of text we just created to the file. Compile this. He's okay, so we can close him off. Last geometry item is the flat grid. So we create the variable again. We specify grid this time, geometry ID of this, and then the width, the depth, the number of divisions in X, number of divisions in Z, and then we output the string. Compile him, he's okay, and let's close him off. Alright, so that took care of the first part here for all the geometries. Next thing I output is all the materials. So here you see we go through a for loop. For every single material we have in memory, we call output tree again. Inside of the material class, we need to create a function called output tree. So inside material.h, we add our output tree function, and then inside of the CPP file, this is what we add. We have output tree, so we create our string. We specify we're going to be using a material. The material ID is this. And then we check for our non-default values. So our ambient, if it's not the default, then we output ambient, red, green, blue, and alpha. We do the same thing for diffuse and for emissive, and finally for specular and shininess. And then once we have our string, we just output that to the log file using our pointer to our error handler. Okay. So we've outputted our geometry, we've outputted our material. Next we have our textures. So again, we go through the container that holds all of our textures, and we call output tree. So inside of our texture class here, we need to create a new function, output tree, and inside of texture.cpp, I'll put it right here at the bottom. We're going to specify texture. Texture ID is this, and if we have MIP mapping set to 0, then we specify MIP_0. If we have filter quality not equal to 4, then we specify the quality factor. If the solid value is equal to 0, then we specify solid is _0. And then we also have the file name for the texture. So we specify here file _%s, and then we pass in the file name of the texture. Lastly, we need to output this to the log file, so we use our pointer to our error handler to pass in the string that we just finished creating. Let's go and compile this, and returning back to scene.cpp. Well, the next thing we have is our texture transforms. So again, we go through our loop for our container, and for every single texture transform, we call output tree. So inside TextureTransform.h, we need to create that function. And then inside of here, we'll implement what it does. We specify it's a texture transform. The ID number is this. If the center x and y is not equal to 0, if either of them are not equal to 0, we specify the center. If we have a rotation, then we specify it. If we have a scale that's not equal to 1, 1, then we specify it as well. We also have translate. If it's not equal to 0, then we specify translate. And lastly, we just output everything to our file. Oh, we made a mistake here. We're missing error handler, which means this guy needs to include core.h. Guess we missed compiling that earlier. Let's go and compile it now. Okay, he's good now. Alright, back inside scene.cpp. We want to also save all the fonts. So we go through our font structure, calling output tree for every single font we have loaded in. Inside font.h, we're going to define our output tree function. And then inside font.cpp, we're going to output the following. We're going to put // font, and then we're going to display whether it's monospaced or not. So if it's monospaced, if m_b monospace is true, we're going to output a 1, otherwise we're going to output 0. And then the texture file that we're going to be using is going to be associated with a specific texture number. So we can get that texture ID number from a member variable, and we're going to just output it here into the text string. Let's go and compile him and move on. Next thing, we have our lights. So for every single light source, we're going to call output tree. So going into our light class, light.h, we're going to create a pure virtual function, virtual void output tree equal to 0, and then this will force all of the light sources, the directional point and spotlight, to also have that function. So here inside light directional, we're going to add output tree. Inside light point, we're going to add it in, and inside light spot, we're going to add it in. Now we need to go inside of the CPP and actually implement these. For the directional light, we specify // light directional. The light number is this. If it's turned off, we're going to specify on is equal to whatever the value here is. We save the ambient color of the light source if it's not the defaults. So there we go, we pass in the ambience. We do the same thing for the diffuse color and for the specular color. Lastly, directional light has a direction, so if it's not equal to 0 for every single parameter here, we're going to specify here's the x, the y, and the z component. And then finally, we use the error handler to output the data to the file. Let's go compile him, close him off, and move on to the next light source, which is the point light. So again, we specify this is a light point. The ID number is this. And if the on value is equal to false, we then output it. We specify the ambient, diffuse, and specular colors, like so. And then we also have attenuation for a point light source. So we specify the constant, linear, and quadratic values, and we also have position for the light source as well, x, y, and z. And then finally we save everything to the log file. one more light source, and that's the spotlight. We specify light spot. Here's the ID number. If it's turned off, we specify on is equal to this, and then the ambient color, diffuse color, specular color, we output all of those to our string. Attenuation, position, and direction are also part of the spotlight, so we need to specify those. And then finally we have the cutoff and the exponent. So if they're not the defaults, we're going to output them, and then finally we're saving everything to a log file. Okay, moving back to scene.cpp. We've saved the fonts, we've saved the lights. Next thing we have is we have our tree structure for a scene graph. So we output a string here called scene graph construction, and the way we do this is we check to see if there actually is anything in the scene graph. If there is, then this node structure will be greater than 0. If there isn't anything in here, then we just skip over it and move down below, which just draws another line like this, and then we change our error handler string here to be no error, because that's what we expect to have when we exit the program. But going back up here, if there is something inside of our scene graph, we then call output tree. An output tree is going to be responsible for going through the scene graph structure recursively, so it goes through everything inside of the scene graph and saves all the values inside of the log file. So to implement this, we need to go inside of our node class, right here, and start implementing some stuff. The output tree function is going to be slightly different for the recursive call. We're going to have output tree, but this time we're going to pass in a value here, and the value is going to specify how deep we are inside of the scene graph. So by default, if we don't pass in any parameter, it's going to be set to 0, and then from then on, and as we recursively call this function, we're going to be changing the depth value. So by default, we're specifying a pure virtual function like so, and this forces all of the following node classes to also implement this function. So we'll go inside NodeLight.h, implement output tree with the default value for the depth equal to 0. We'll go into NodeShape, specify that as well, and NodeTransform. And let's start off with the NodeLight. First thing we do is we create this variable, which is going to contain our string that we output to the log file. We check to see if the depth value is greater than 32. If it is, we immediately write invalid depth and we specify the depth value. So remember, OpenGL has a limit of 32 deep. So if you have something nested beyond 32, then we won't be able to render it properly anyway. So just to make sure that the user sees that, I display this invalid depth value here. Otherwise, what we do is we clear the output string to nothing, and then we start adding plus signs to it. The number of plus signs we need is equal to the depth that we have. So for every single depth value that we passed in here, we add an extra plus sign using the string concatenation function call. Then we specify the light parameter values. So we say light, and then this light is using which light ID number from the structures that we've already loaded up above. So here we just display the light number is going to be equal to the pointer that's pointed by this member variable here. We then save all of this to the log file, but because this is a recursive call, we need to go and then check to see if there's anything else we need to go and call this output tree function call with. So if there's something nested underneath us, we increment the depth value by 1 and then call output tree for whatever's in there. Otherwise, if it's at the same level as us, so there is no sort of parent-child relationship, we're both siblings at the same level, then we call the output tree function call again, but this time for the same depth level. So that's how we handle the node light. and let's go in and implement the node shape now. Again, we create a variable to hold the string, and we check to see if there's invalid depth value here. If there is no invalid depth, then we specify how many plus signs we're going to need, and then we say, okay, this is going to be the shape, and we specify the name of this shape, if it exists, is going to be this. We specify the ID number for the geometry that the shape uses is this value here for the pointer. The material, if it exists, we're going to specify it, the texture, and the texture transform. Finally, we output everything to the text file, and then because it's recursive, we go into the depth if we have a parent-child relationship. Otherwise, we use the same depth value to output the next node's parameters. Let's go and compile this. Looks like we missed something here. Oh, right. We're getting this error here because it's saying that m_psz name is a private member declared in Node. If we just go in here under the definition, we see it's listed under private. If we move this guy from a private to a protected, our inherited members will still be able to access this variable, but if you're not inside of this class, then you won't be able to access it. So it's similar to private, but protected means that inherited members still have access. So let's go and compile this now. Okay, he's okay. And that should finish off node shape. So we only have one more left, and that's the node transform. Node transform. Again, we check to see if the depth is valid, add all the plus signs for the correct depth, specify we're using a transform here, and if the name exists, we output it. If it's visible, we output it. If the translate value is not the default value, we output it. Same thing with scale, same thing with center. So we have X, Y, and Z components. And we have rotation axis and the rotation angle. So X, Y, Z for rotation axis. And then we output everything to the log file. Finally, again, we go and inherently go through the parent-child relationship by increasing the depth by 1 if we have something nested underneath us, and using the next pointer if we have something located beside us. Let's go and compile this, and I think that's it now. So we should be able to compile this, or build it anyway, and everything should be okay. Now the only thing we need to do is actually call this new function, output Scenegraph, to a log, so we can see the results. And a good place to do that would be inside of Scene Initialize. After we initialize and load everything, let's just call it right here. So after we've loaded everything into the Scenegraph, but before we render it, we're going to output everything to the log file. Let's go and compile this, or build it, and then run it. So all we have right now is the ground and that lamp object. Now if we go into the directory where we just ran this, we should be able to see everything that was loaded. So here we are inside of the build /_debug directory. We have our log.txt file. If we open that up, we can see that this file was just created. At the top, we have all the geometries that we loaded into memory. So we have a box, a cylinder, a grid, another cylinder. Some of these we didn't display onto the screen, obviously, because all we saw was the grid and the compiled geometry. We also have the compiled geometry listed here. We have this guy and another compiled geometry here. So we actually had two. And then the materials that were created for us, some of these were created from the Caligari file, some of this were created by ourselves. So you can go through, take a look to make sure that all the values here match what the values you are expecting. We didn't have any textures, we didn't have any texture transforms, we didn't have any fonts, but we did have a light source, so this here was loaded in, and then we have our scene graph. So we had a transform, not named or anything, just the default, and then nested underneath that, we had this shape node which had the geometry ID 4065784 loaded in. So if we look for this geometry ID 4065784, 4065784, this one here. So this is the geometry for a flat grid. And the material that it's using is 4095536. So 4095536, this one here. So this is the flat grid color that we're using. So red, green, blue, sort of the greenish color that we see on the ground. Then underneath that we had a transform that was named lamp.cob. So this is our Caligari file. And it's comprised of two geometries. We have one transform called sphere and another transform that has a blank name by the looks of it. This one here is geometry ID 4128008, which is this guy here, and it was compiled, so we don't actually have any additional information about it. And the other guy, which is located right here. So as you can see, the output seems to be working, and you can go through and debug relatively easily. If you wanted to, you can now take all this code here, cut and paste it into an LVL file, and use it as your new file that you want to load in. Obviously, the compiled geometry will not get loaded because it's been commented out. What you could do is modify your LVL loader so that you can also specify Caligari files internally here. And then, when you output your tree structure, you could just specify that cob file that you want to load in, and everything will work perfectly. But I'm not going to bother with that because that's just a little bit of extra work that you guys should be able to handle on your own. And if you are finding my videos helpful and you can support my website, please help me out. You can do that by buying anything from the store or from the membership section here, or even by clicking on any of the Google ads or donating. All of this will help me out to keep my website up and running